Okay, last factor, we're going to look at the solvent. Solvent can facilitate SN1 and SN2 reaction if you use it appropriately. All right, just review real quick. So we have product solvent. This type can form hydrogen bond by with itself, right? And can stabilize the whole thing, cation and anion. We love for an SN1 reaction because of carbocation. And for a product solvent, this guy can stabilize only the cation, right? Leave anion alone to leave the nucleophile reactive, appropriate for an SN2 reaction. Okay. One thing you should know about product solvent, when you practically we use these guys as a nucleophile and a solvent at the same time. Right. Basically, you have the alkyl halide, you just dip into ethanol solution, and that's it. You don't have to add anything else. So we use ethanol as a nucleophile and a solvent at the same time. All right, but in terms of a product solvent, you're going to see a reagent, whatever strong nucleophile they add for an SN2, and then you will see the solvent at the bottom of the arrow, the reaction arrow. Okay, because they don't react as a nucleophile, right? All right, you will see it. Let's take a look right here. Predict the mechanism of each reaction and predict the product for the substitution reaction. All right, let's start with A. How do you think about it? So you look at one thing at a time. Just ignore everything else except look at just this guy. Okay, the alkyl halide. What type of alkyl halide is this? You should be able to tell this is a secondary alkyl halide, which means that it can go both SN1 and SN2. All right, secondary alkyl halide can go both SN1 and SN2. Carbocation is not as stable as tertiary, but it's stable enough to exist, right? SN2 is not completely sterically hindered, it's not completely blocked backside attack. So an SN2 can happen, so either one. Now, look at the nucleophile as a tiebreaker. Strong or weak nucleophile? Oh, this is weak nucleophile. This is weak, so we go SN1. This favor SN2, so SN1 competes successfully, all right? So the first in the substitution in A gonna go on SN1. When this guy go SN1, you form a carbocation, so racemic mixture, racemization, so watch out though. You should get a racemic mixture there. Methanol attack. Oh, no, there's supposed to be methanol on there. Right? Or CH3, not Cl. I'm wrong. So or CH3. Okay? So it's supposed to be methanol can attack from the front and the back. At that position, you get racemic mixture. All right, move on to B. Start with the alkyl halide. What type of alkyl halide is this? An SN2, it's a primary alkyl halide based for an SN2. All right. Now let's check the nucleophile if it's also SN2. Iodide, strong or weak nucleophile? Strong, go on SN2. Look at the solvent, DMS or dimethyl sulfoxide is a type of a product solvent. So facilitate SN2, totally B go SN2. If this reaction go SN2, iodide will attack at that carbon right there, right? Backside attack, so you should get inversion of configuration. But that carbon is not chiral center, so you just get one product there. All right. All right, C down here. So start with the alkyl halide. Secondary alkyl halide. What reaction? What mechanism? An SN1 reaction. Right. Also, you can go both SN1 and SN2. This is secondary, right? Carbocation stable enough and it's not too sterically hindered, so SN2 works. If you look at the nucleophile, strong nucleophile favor SN2. Acetone, a type of polar A product solvent, will leave nucleophile alone, so good for SN2. Totally go SN2. If this guy were to go SN2, what product did you get? Inversion of configuration, so sulfide will attack that carbon, backside attack. Get that. Get that? All right. Last one, D. Look at the alkyl halide first. Secondary. Can go both SN1 and SN2. Weak nucleophile. Totally go SN1. This reaction go SN1. All right. So should go SN1. You should get two products. However, that carbon there is not a chiral center, so you get only one product there. All right. Okay. All right. We're going to use this for this application. We're going to do synthesis problem. Okay.